This explainer starts with the core problem in standard multi-head attention, then progressively walks through the optimizes families used in modern transformer systems. Standard multi-head attention is expressive, but it becomes expensive for several different reasons. The score computation is dense. Every token compares against every other token, and during decoding the model, must keep a growing key-value cache for every layer. At scale, moving all of that cache data through memory can become the real bottleneck. Before looking at improvements, separate the bottlenecks. There is the dense compute problem, the key-value cache problem, the memory bandwidth problem, and the deployment problem. Different optimized attention methods attack different parts of that list. FlashAttention is the least disruptive optimization because it keeps exact softmax attention. It improves how attention is executed by tiling work into fast on-chip memory, reducing I/O. The gain is speed and memory efficiency, but the limitation is important: the attention pattern is still dense. So FlashAttention improves execution without changing fundamental connectivity cost. Multi-query attention targets inference memory directly. Instead of keeping separate keys and values per head, all query heads share a single key head and a single value head. That makes the KV cache much smaller and cuts memory traffic during decoding. Benefit of MQA is obvious for production inference: much less memory and faster serving. The limitation is reduced flexibility because every query head now reads from the same key value representation. That can hurt quality compared with full multi-head attention. Several query heads share a smaller number of key value heads, so you recover more representational flexibility while still shrinking the cache. That is why group query attention is often the practical choice in modern large language models. Each token attends only to a neighborhood instead of the entire sequence. That makes long context processing much cheaper, but the limitation is clear. If the task needs arbitrary long-range interactions, pure locality can miss them unless you add recurrence, memory, or occasional global paths. Block sparse and long-form style attention generalize locality. Most tokens attend through a limited sparse pattern, while a smaller set gets broader access. The benefit is a better balanced efficiency and global information flow. The limitation is that the sparse pattern becomes an architectural assumption that must match the task. Linear attention changes the formulation more radically. Instead of explicitly computing all pairwise interactions, it rewrites attention into forms that scale more gently with sequence length. The benefit is much better long sequence efficiency. The limitation is that it usually stops being exact softmax attention, so quality and stability become much more method dependent. The right optimization depends on the bottleneck. If you want exact attention with a faster kernel, use FlashAttention. If serving memory is the problem, use MQA or GQA. If context is huge and structure matters, use local or sparse attention. If asymptotic scaling is the priority, consider linear attention. These are not interchangeable tricks. They solve different problems.